Albert Einstein's philosophy of science, circa 1916. There's no reason to assume that Albert Einstein's philosophy of science will be on a par with his physics, at least as it was expressed in his Relativity, the Special and the General Theory, 1916. And indeed, it isn't. This means that, in terms of this essay alone, his words have been focused upon not because of their insight or profundity, but primarily for their historical and philosophical interest. When referring to relativity, the special and the general theory, Einstein himself mentioned philosophy, or more accurately, he wrote that in his book he intended to give an exact insight into the theory of relativity from a general scientific and philosophical point of view. So, in the case of this essay, Einstein's philosophical point of view as it concerns science, rather than specifically relativity, will be concentrated upon. The following will attempt to show what Einstein thought, at least in 1916, of science, actually physics, itself. It can therefore be asked if Einstein's account of science physics corresponds to what other physicists, scientists, thought at the time. In addition, we'll see what Einstein thought of the layperson's view of science. In terms of detail, Einstein's philosophy of science only takes up 3 paragraphs in a book of 132 pages, plus a few words on the philosophy of geometry, which will be covered later. And all that's in one appendix, Appendix 3. In terms of relativity, the special and the general theory itself. This book began life as a short paper, and it was eventually published as a book in 1916. My English edition dates from 1920, which is the same edition as in the image above. This book's aim, to quote Einstein's own already quoted preface, was to give an exact insight into the theory of relativity to those readers who, from a general scientific and philosophical point of view, are interested in the theory, but who are not conversant with the mathematical apparatus of theoretical physics. Oddly enough, there is a fair amount of mathematics in this book, far more than you'd see in most, or even all, contemporary popular science books. Science is observation, induction, and cataloging. Albert Einstein offered his overall account of what laypersons, and possibly even some scientists, took science to be, at least in 1916. Firstly, he stressed induction and observation. He wrote, "From a systematic theoretical point of view, we may imagine the process of evolution of an empirical science to be a continuous process of induction. The layperson's basic take on science is that science is essentially inductive, or at least this is what's usually believed to be the layperson's view. The problem here is that most laypersons don't actually philosophize about science at all, and they rarely, if ever, use the word induction or inductive. That said, some philosophers tell us that a person may have the concept of a word without actually ever using the word itself. So laypersons may have the concept, induction, without ever using the word induction. What's more likely is that laypersons stress observations, as do scientists themselves." So Einstein continued, "Theories are evolved and are expressed in short compass as statements of a large number of individual observations in the form of empirical laws, from which the general laws can be ascertained by comparison. Thus, individual observations are often believed to drive the entire scientific show. At least that's the layperson's view. But once again, only empirical research can establish what laypersons actually believe. Yet, anecdotally, this does seem to be the usual position. Anyway, on this picture of science, scientists go outside and observe. Alternatively, scientists carry out experiments and then simply observe what happens. According to Einstein's take on the layperson's take, scientists collect all their observations together into a large pot, or at the least they collect their statements about the observations together, and then they attempt to make sense of them. Or, in Einstein's own words, scientists extract empirical laws from their observations. In this bald form, it's hard to know what all that even means. Clearly, innumerable other factors would be required in order to extract empirical laws from observations alone. And then the situation becomes even more complicated when general laws are ascertained from those observations and empirical laws. Einstein was absolutely correct to detect the profound naivety of this view of science. And that's why he went on to write the following words. Regarded in this way, the development of a science bears some resemblance to the compilation of a classified catalogue. It is, as it were, a purely empirical enterprise. Thus, scientists are, or were, often seen as merely cataloging nature, or cataloging their observations of nature. This is almost like scientific stamp collecting, as with, to be a little crude, Francis Bacon, 1561 to 1626, and his own philosophy of science. In this way, it was believed that everything can be kept scientifically kosher, or empirical. The reader might have detected unwritten scare quotes around Einstein's use of the word empirical. Of course, one can immediately ask why scientists were cataloging the things they were cataloging in the first place. Why were they observing those parts of nature and not other parts? Why did they want to compile the things they compiled and not other things? In other words, there must have been prior factors, above and beyond what it is they observed, that brought about those very same observations. Einstein himself then explained why this view is both simplistic and naive. He continued, but this point of view by no means embraces the whole of the actual process, for it slurs over the important part played by intuition and deductive thought in the development of an exact science. So it's clear that Einstein wasn't actually ruling out entirely the layperson's view of science. This means that observations, and even cataloging, are indeed part of the story of science. That said, these things, according to Einstein, by no means embrace the whole of the actual process. And it's here that Einstein adds intuition and deductive thought to the development of an exact science. Einstein also wrote the following. The theory finds the justification for its existence in the fact that it correlates a large number of single observations. That reference to a correlation of a large number of single observations is a perfect account of some kind of inductive process. For example, from the observation, and then correlation, of a large number of white swans, a subject may or will conclude that all swans are white. Alternatively, and in Einstein's case, a scientist may develop a, to use Einstein's word, theory about swans and why they are all white, which may even include natural laws of some kind. Einstein had also already mentioned induction, though in a critical way, when he wrote, "We may imagine the process of evolution of an empirical science to be a continuous process of induction." One may also ask how a scientist correlates a large number of single observations. Alternatively, how someone connects the dots about all swans being white. After all, if the theory finds its justification in the fact that it correlates a large number of single observations, one may suggest that theories were already required in order to enable those correlations. In simple terms, already existing and accepted theories would have been required or needed in order to find a new theory. In the white swan's case, in order to conclude that all swans are white, the person who concluded that must have already accepted various other things about swans, the color white, the whiteness of swans, the nature of observations, etc. Intuition and deductive thought. For me personally, Einstein's stress on what he calls intuition and deductive thought, in the quote above, is a little odd. Then again, that may simply be because I live in different times and use different jargon about these same issues. In any case, many philosophers of science today would stress theory here, not intuition and deductive thought. Of course, theory is also intimately tied to both intuition and deductive thought. But firstly, the word intuition. In philosophy and mathematics, that word often has very specific and indeed technical meanings. See here. So one wonders if Einstein used it in that way himself. Perhaps Einstein simply meant speculation, theorizing, or free thought by intuition, that is, all thought that goes above and beyond the observational data. Indeed, all the thought that's also required to make sense of the observations, and even bring about the observations. So what about Einstein's deductive thought? Well, in a general and perhaps vague sense, if we have observations or statements about them, then we can deduce things from those observations. That is, the observations don't stand on their own. Scientists need to make sense of them, and they can also deduce, not always logically, other things from them. However, Einstein used the word deductive thought because later he says that. The investigator develops a system of thought which, in general, is built up logically from a small number of fundamental assumptions, the so-called axioms. This is Einstein, provisionally, treating physics as a kind of pure deductive logic. That is, instead of premises from which a conclusion can be derived, or axioms in mathematics, which lead to theorems, we have observations and/or fundamental assumptions, which lead to theories. And in fact, Einstein himself says that we call such a system of thought a theory. Of course, all this is very neat and tidy, and science, or scientific thinking, isn't really, or always, like that. Einstein also used the words, the so-called axioms, and that is a roundabout admission that physics is physics, and pure logic is logic. Truth. Einstein concludes by saying that if the theory correlates a large number of single observations, then it is just here that the truth of the theory lies. Readers will have noted the scare quotes around the word truth, and this is an extremely important aspect of Einstein's philosophy of science and indeed of science itself. The layperson often sees truth as a central goal of all science, yet many scientists have never seen it in quite the same way. And that's because truth is a tricky character for scientists. In any case, elsewhere in Relativity, the special and the general theory, Einstein explicitly states that in geometry, if not science, truth doesn't really have any role. Or if it does, then the truths of geometry are very different to the truths spoken of by laypersons and even scientists. For example, take Einstein's words on Euclidean geometry. He wrote, "We cannot ask whether it is true that only one straight line goes through 2 points. We can only say that Euclidean geometry deals with things called straight line, to each of which is ascribed the property of being uniquely determined by 2 points situated on it. The concept true does not tally with the assertions of pure geometry, because by the word true, we are eventually in the habit of designating always the correspondence with a real object. Geometry, however, is not concerned with the relation of the ideas involved in it to objects of experience, but only with the logical connection of these ideas among themselves. Put basically, Einstein believed that truth in pure geometry, like logic, is essentially a matter of convention. In terms of this stress on conventions, and indeed other things, Einstein might have been influenced by Henri Poincaré. They actually met in 1911. See here and here. Alternatively, and as Einstein later says, geometry is a matter of logical connections, or what can be derived from axioms. What is important here is that geometrical truth has nothing to do with what Einstein himself calls correspondence, or objects of experience. Nonetheless, Einstein later did tell us why laypersons tie both geometry and truth to physics, or at least to the physical world. He continued, "It is not difficult to understand why, in spite of this, we feel constrained to call the propositions of geometry true. Geometrical ideas correspond to more or less exact objects in nature, and these last are undoubtedly the exclusive cause of the genesis of those ideas." Einstein's words above highlight a long-running debate in the philosophy of mathematics. In that debate, philosophers have attempted to ascertain which way the temporal and metaphysical arrow points. Thus, 1. From exact objects in nature to mathematical ideas, or 2. From mathematical ideas to objects in nature, which needn't be seen as being exact anyway. However, Einstein concluded by saying that geometry ought to refrain from such a course of seeing truth in the same way as laypersons do, i.e., as a matter of correspondence with objects in the physical world. To repeat, most laypersons, as Einstein has just hinted, do see truth as some kind of correspondence between what people say or write and the world, or aspects of the world. For example, the statement, "all swans are white," is believed to be true because it is seen to correspond with the fact that all swans are white. Each italicized word in that sentence presents its own problems. Of course, there are many difficulties with what's called the correspondence theory of truth, which can't be tackled here. But in terms of Einstein's own position, after putting scare quotes around the word truth when it comes to pure geometry, he then writes that truth, at least partly, consists in corresponding with the empirical data,